Okay, today we start chapter 6, the last chapter of this trimester. It's polygons, quadrilaterals. So we're moving beyond triangles, although we're always going to be using triangles as a base for many of the things we do. All right, and in fact, today we're going to be looking at specifically at the polygon angle sum theorem. I can find the sums of the measures of the interior and exterior angles of polygons. All right, polygons you've worked with before. Polygons, and here's a good definition for a polygon. Okay, it's a closed figure, meaning it's not open. It's in a plane, so it's two-dimensional. It has to have at least 3 sides that are segments, and the sides intersect only at the endpoints. No curves, no gaps, no overlaps. Okay, so are these polygons? No, it's open right here. Okay. This one will be yes. They're all straight lines. It's closed. It's flat. It's all those things. Okay. At first glance, this looks like a no because this is overlapping. But if you look at it as like this is one shape, this is another, then it could be a yes. All right, and this last one looks three-dimensional. Looks like a cone. Okay? If we don't look at that as three-dimensional, it looks like it's not a polygon because looks like a shape that's kind of like a little oval-y shape. And then that curve right there keeps this from being a polygon also. Okay? You can classify a polygon by the number of sides that it has. Okay, we know that a 3-sided polygon is a triangle. 4-sided is quadrilateral, which literally means 4 sides. 5 is a pentagon. 6 is a hexagon. 8, octagon, like a stop sign. 9, nonagon. 10, decagon, like decade. 12, dodecagon. N, we could call that an n-gon. Basically, n represents any number of sides. So if it was like a 30-sided figure, we'd call it a 30gon. All right? Diagonal is a segment that connects non-consecutive vertices of a polygon. So if I'm looking at like all of the diagonals from this point or this vertex, I'd have one here, one here, one here, one here. Okay. This one and this one are consecutive. They're right next to each other on the outside of the shape. Same thing as this one and this one. Okay, so they're inside between points. Convex polygon is a polygon that has no diagonal with points outside the polygon, just like the one we showed there. Okay. A concave polygon has at least one diagonal with points outside the polygon. So if I did one from here to here, I'd have points outside the polygon. It also, it's like a cave. Concave. Imagine a little dude here, walks in here, goes into the cave. Okay. Not a real good definition for it. This would be the much better definition, but just an easy way to kind of think about it. All right. Classify each polygon, tell whether it's concave or convex. I look at the number of sides, 1, 2, 3, 4, 5, and it is convex, so I'd say convex pentagon. This one, I got 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's a spot right there which makes it concave. Concave nonagon. All right. Next. It says use the straight edge to draw the shape assigned. Yeah. Divide your polygon into triangles by drawing all possible diagonals from one vertex. Not going to have you do that. We're going to do this kind of together instead. Using your it says use your triangles to find the sum of the angle measures for your polygon. All right, so a triangle, okay. I can't draw any diagonals. Okay, cannot draw any diagonals because each side is right next to another one. Okay, and so three-sided shape. I've got one triangle. This total angles inside there are 180 degrees, like we've already talked about. Okay, if I go with a quadrilateral. Okay, I'm going to draw one diagonal, and from that I can see that I have two triangles, right? 1, 2, and then if you know to look at the number of degrees in here, I'm going to look in here and I'm going to say, well, this is 180 for that triangle. That's 180 for that triangle. So my total interior angle sum is going to be 360. All right. If I draw a pentagon, I'll do my best. This is not necessarily a regular polygon. It does not have to be. We'll talk more about what that means in a minute. Okay, but five-sided polygon. Okay. If I now draw my diagonals, let's say from this point, I have 1, 2, those are supposed to be straight lines. Okay, and I've got 1, 2, 3 triangles. Okay, and 180 here, 180 here, 180 here. 3 times that 180 gives me 540. If I did that with the hexagon that's right here, 1, 2, 3 lines, and I've got 1, 2, 3, 4 triangles, and so I got 180 here, 180 in here, 180 here, and 180 here. 4 times 180 gives me 720. And you can pretty quickly realize that there's a pattern happening here. This would have 5 triangles, and it'd be 5 times the 180, which would be 900. This would be 6, and I'd have 6 times 180, which would be 1080. And for n, this is kind of what's really the important piece out of all of this. Notice that this is always 2 less than the number of sides. Okay, so I'd say n minus 2. And whatever that number is, that's what I'm multiplying times 180. Which leads us to the polygon angle sum theorem. The sum of the measures of the angles of an n-gon is, n represents the number of sides in that polygon, right? N minus 2 times 180. All right. Now, we're going to look at another piece here as well. Using the same figures that I did in the previous activity, we're going to extend exterior angles from each vertex. Measure each angle, find the exterior angle sum. And we're not going to actually measure it, we're going to think it through. All right, so if I go to the quadrilateral, right, and I extend this out, right, and there's my exterior angle, extend that out, exterior angle, extend that out, exterior angle, extend that out, exterior angle. Okay. Don't really know what they are because I haven't measured any of these, but let's just say this. If I start, let's say I just start right here, and I go around here, around that one, and back, and that's 360 degrees. Okay. On the triangle, I could do the exterior angles on that too, right? Right there. Right there. And right there. And so Oops, I did that one bad, didn't I? One doesn't match up with the other ones. Next in that one. So they're all going the same way. So that one, that one, that one. And again, as I go around, that's 360 degrees. Okay? Same thing here. If I extend this out, I'd have an angle here, 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 and again, all the way around. Those are going to total up to 360 degrees. So regardless of the number of sides in this, exterior angle sum is always going to be 360. No matter what. So Polygon exterior angle sum theorem says that some of the measures of the exterior angles of a polygon, one from each vertex, is 360 degrees. All right, a couple more things, or three more terms. Equilateral polygon, all sides congruent. Equiangular polygon, all angles are congruent. A regular polygon is both equilateral and equiangular. Okay? All the sides are congruent, all the angles are congruent. Okay, so let's put some of this to work here. So if I'm finding the sum of the measures of the angles of each polygon, if it doesn't say which ones we're talking about, you can assume we're talking interior. Okay? Unless specified otherwise. Okay, sum of the measures of the angles of each polygon. Okay, octagon has 8 sides, or n equals 8. So all I'm doing is, remember it's, the interior is going to be n minus 2 times 180, right? So I'm going 8 minus 2 times 180. That's 6 times 180, which is 1,080 degrees. Dodecagon, n is 12. So 12 minus 2 times 180, that's 10 times 180. And that gives us 1,800 degrees. 50gon, obviously n equals 50, so we would do 50 minus 2 times 180, or 48 times 180. And 48 times 180 is 8,640 degrees. All right. These shapes obviously are not regular polygons. It says find the missing angle measures. All right. But I'll count the sides. I got 1, 2, 3, 4. Okay. So I'm going to use n minus 2 times 180. And so that's 4 minus 2 times 180. 2 times 180 is 360. Every quadrilateral is 360 degrees in there. All right, and then I'll look at what I have here. I've got 71, 112, 48. Add those together, I get 231. Okay, so if I take 360 minus the 231, that'll give me x, and x is equal to 129 degrees. On the next one, I've got 1, 2, 3, 4, 5, 6. So I have 6 minus 2 times 180, 4 times 180, and which is 720 degrees. All right, and when I look at what I have, I got that right angle, which is 90, plus 124, plus 150, plus 93, plus 130. When I add all this together, I get 587. So I take 720 minus 587, and that equals 133 degrees, which is what x is. Last one here. I got 1, 2, 3, 4, 5. So 5 minus 2 times 180. 3 times 180, that equals 540 degrees. Okay, I've got 88 right there, plus x plus 63, x plus 47, 116, and x plus 46. And when I add those all together, it equals 540. Okay? All right, I'm going to combine all these numbers. I add all those up. I got 3 x's. The non-x terms add to 360. Subtract 360 from both sides. 3x equals 180. Divide by 3. X equals 60. Now, it said to find the missing angle measures. Okay? On the previous ones, the only thing that was missing was those x's. So now I need to take and plug 60 in here. 60 plus 63, this is going to be 123. 60 plus 46, that's 106. 60 plus 47, that one's 107. All right. That says find the measure of an interior angle and an exterior angle of each regular polygon. Okay, triangle, you know it's 180 degrees. And it's regular, so equilateral, equiangular. Everything's congruent. 180 divided by 3 is, this is my interior angles, 60 degrees. Exterior, 360, all the way around, right? Divided by 3, 120 degrees. Hexagon, interior. That's 6 minus 2 times 180. All divided, and then that equals 720. So for my interior angles, I'm going to take 720 divided by 6, and it gives me 120 degrees. Okay, now if you hadn't noticed this yet, well, maybe you will on this one. Exterior, I'm going to take 360 divided by the 6, and I get 60 degrees. Okay, take a look at these here. 60 and 120, add them together, you get 180. 120 plus 60, you get 180. So you can use that as a shortcut on some of these. All right, 20 gone. So I got 20 minus 2 times 180. That's 3,240 degrees inside. Okay, so each interior angle is going to be 3240 divided by 20, which is 162 degrees. Okay, I can do 360 divided by 20, or I can just do 180 minus 162, and it's 18 degrees. All right, done. Next problem. Measure of an exterior angle of a regular polygon is given. This is the measure of an exterior angle. We're going to find the measure of an interior angle and find the number of sides. Okay, we're going to kind of work backwards from this. Okay. First thing is don't write this down. Okay, this is one way of thinking about it. Don't write this down. Might not be the most efficient method. All right, we got n minus 2 times 180 equals the sum of the interior angles, okay? And so if I take that n minus 2 times 180, and I divide it by n, I know I'm going to get this, because that's an exterior, so 180 minus 45 tells me that the sum of the interiors is going to be, an interior angle, not the sum of the interiors. The interior angle is going to be 135 degrees, right? And so that's equal to 135. Okay, so if I'm trying to find the number of sides, I could use this formula right here and solve for n. Doesn't look very friendly. Okay, here's another thought. For exterior, 360 divided by n equals 45. Okay, if we multiply this times n and this times n, we get 360 equals 45n. Then if we divide this by 45, we get n. And 360 divided by 45 is 8 sides. Okay? Probably the easiest way to do it. So for this one where I have a 10, that's my exterior, right? Okay, so the interior is going to be 180 minus 10, or 170 degrees. Okay, for n, we're just going to do 360 divided by that 10, and it'll tell me the number of sides, which is 36 sides. All right, and the last type of problem, sum of the interior angle measures of a regular polygon with n sides is given. Okay, find n. So I know that n minus 2 times 180 is equal to 2340. Okay, because that's the sum of the interior angle measures. Okay, and I know that that's n minus 2 times this will give me that sum. All right, so now I'm just going to take and divide this by 180. And so I end up with n minus 2 equals, this divided by that is 13, add 2, n equals 15 sides. Same thing going here, n minus 2 times 180 equals 1440. So divide this by 180. N minus 2 equals 8. Add 2 to both sides. N equals 10 sides. And that's it for today. More to follow tomorrow.